All right, guys. Next one we're going to do is counters. So hopefully you're following along. We've done the three-wire. We've done a little bit of timers. We've done some online editing. Now let's look at the counters now. So let's go into our main routine. Let me get myself out of the way and we'll just bring up the whole program onto the screen here. Okay, so you've opened up your base PLC program. Like I just have mine as says test project. Remember, it's a good idea to have like a base PLC program with everything set up, and you just save it without any tags, without anything within the ladder logic, and then you can bring it up anytime that you want within class. It just saves yourself the time of like opening it up and trying to find the right processor and everything like that. The other thing to note is that sometimes it will open up and you don't have the menu on the side here with everything that we had before. So the way to bring that up is you go to View, and then you go down to Controller Organizer. So click on that guy. Beautiful. Okay, then we've got our tasks here. So I'm going to click on tasks. Okay, and then right there you can see that we have the main program, and then below that we have main routine. So we're going to click on this guy and open up that guy. Right, that's going to obviously open up your main routine, but that opens up, that allows you to get to the actual main routine. If we go to the controller test project, then we'll be able to look at tags. So it looks like I don't have any tags set up, like no counters, no timers, or anything at the moment. All right, guys, so let's go back to the main program. Okay, remember that I can now go back and forth here, or I can go back and forth on these tabs above here now that I have these guys open. So I'm going to go back to my main routine there, and then let's move this bad boy over so we got lots of area to work with. Okay, so first thing we need is we need to have a counter, right? So let's come up here. We've got alarms, bit, timers, and counters. Beautiful. We already looked at the TON, the TOF. That's cool how that comes up like that. I like that. And we had the RTO, the retentive timer. So now let's cover the last three instructions. Well, we've already covered the reset, but we're going to use that again for the counter. We're going to use the count up and the count down. So normally I would do like a video on the count up, and I'd also do a video on the count down, and then I would do an up down counter. But I'm going to grab these guys and just create an up down counter for this one, and that should be able to show us all of the instructions that are available with the counter. So again, I'm grabbing that guy, bring her down till I see green and drop her in. Okay, then I'm going to create another rung. So I'm going to come up here, not a branch, I need another rung. Beauty. And I'm going to grab the countdown, okay, till she's green and drop her in. Very nice. Okay, then I need an input there. So I'm going to go back to my bit logic here. I'm going to grab an examinative closed, or what they call an examinative on now. I'm going to grab another one down here. So I'm going to have two inputs here that one turned on will send the signal to my count up, another one will send a signal to my count down. Beautiful. Let's address those guys right now. So I'm going into the first word here for my inputs. It has false data and what is that? Readback. We're going to data, and I'm going to use input 0. Beautiful. Okay. And I'm going to now come down, edit the main operand description, and I'm going to call that my count up input. Okay, then I'm going to do this guy. Let's address this one. So we're going through the same steps, going to our inputs, that's outputs. Inputs, come on, Pete. Going to data. Next one available is input number 1, so we'll try that guy. Beautiful. We're going to right click on this guy, edit the main operand description, and this is going to be my countdown. So we rock through those guys pretty quickly, but if you're not clear on how we've set these guys up or how we put the inputs in for the specific bits, then go back to the beginning of the playlist. That's linked below this video in the comment section, and then you'll be able to walk through the steps that we have set up already. Okay, so we've got these guys controlling our counters, but we need to provide a name for the counter. So let's click here. Same as we did with the timer. I'm just going to call this counter 1. Still not clear whether if I can put a space in there or not. I'm going to leave no space there. You guys can tell me in the comment section whether you can have a space there or not. So counter 1. Next thing I want to do is, because that doesn't necessarily create the tag, right? So I'm going to right click on this guy and I say new counter 1. Okay, so we're going to click on that guy. Beautiful. So that creates a new parameter or a tag there. So counter 1 is now, it's already grabbed the data type counter. That's good. So we'll now create that. And as soon as we do that, then the preset and the accumulated value should be able to come in. So that's good. Okay. You can see, so my preset was most likely not going to be a 5. I did a video before just getting ready for this, so I must have created the counter 1 prior to this. Normally this would start off with a preset of 0. So let's start off with a preset of 5. Okay, beautiful. Our accumulated value is obviously 0 because we haven't had any logic come through yet. So that's good. And what we're going to do is we're going to name this guy the same. Let's see if I can click on this and bring up, oh, very nice. Okay, so there's my counter there. So I'm going to use counter 1 as well. And as soon as I do that, then all of the values for the count up have now come into the count down. Okay, so if you've seen this before, in Siemens they have like a function block that's available for count up, count down. I don't believe that function block is available here in the ladder for the Studio 5000. So we have a count up and we have count down. They're both addressed the same. So if they're both addressed the same, then they're going to react the same within the program. And so they both have the same preset and obviously the same accumulated value because they are the exact same counter. One is just going to act as a count up and this one's going to act as a count down. So it's a cool way that you can make an up-down counter with two separate instructions here. Okay, then we also need, as we've seen with the timers, we need to have a reset. So let's put in another rung here. We're going to grab an XIC and then we're going to grab the resets. We're coming back here to timer and counter and we're going to grab the reset, bring her down till she's green. Beautiful. This one here we had input 0, input 1, so this one's going to be our next one, input 2. So let's go to our inputs, going to our data. Next subsequent bit there is input 2 that's available. Beautiful. We're going to, oh, okay, and obviously, like I've already worked on this program, normally we would click here and go to edit main operand description, but it looks like I already had that set up. Okay, so we now need to reset the entire counter. So it's not like we're going to reset just the accumulated value. We're going to reset everything for that counter there. So we're going to come here and we're going to click on this drop-down menu. And it has all of our inputs and outputs, but we need to reset counter number 1. Okay, so we're just going to click on this guy and then click anywhere on the screen. Beautiful. Okay, so everything looks cool now, right? We've got our input here. That's going to be our input 0. Input 1 is going to go to the count down. Input 0 is going to go to the count up. And then we have another toggle switch on input number 2 that's going to act as our reset button. That's going to reset counter 1, which will obviously reset both of these instructions because they are the exact same instruction. Beautiful. Okay, so I said that there's no count up, count down available. So how do I know that? Well, if I come over here and I click on the count up, I'm going to hit the F1 key. And same as with Siemens and Allen Bradley, when you hit the F1, then it brings up the user manual for your PLC. Okay, so this one has opened up in my browser here. And I really like the way that they have this set up. It's really cool how everything's set up for the quick start setups, everything with the logic designer, and then all of your individual bits. And there's just a disgusting amount of information available on every different type of PLC. So here we are on the timers and counter instructions, right? So that has our count up and our count down here. If we look at the count up down, so let's click on this bad boy. It says that for the ladder diagram that it's not available in ladder diagram. So we have to make use of two separate instructions, being a count up and a count down, in order to make an up down counter there. Okay, if we scroll back down and we go to the count up instruction, it provides us with everything that's available here. So it looks at all the different bits of information that are corresponding to the counter. So we'll bring that up in 2 seconds where we can see all of our bits all at once. But it looks like the preset and the accumulated value are both double integers. Okay, and then it has a number of different structures within the counter. So it has the count up, count down, right? So those are going to be the count up and count down for obviously the different instructions that we just placed in there. Those are both Boolean logic. Actually, everything here, except for the preset and the accumulated value, are all bools. So those guys are just a 0 or a 1, an off or an on or a false or a true. So we have the count up, we have the count down, and we have the countdown is not obviously seen here, but if we looked at the CTD, then it would be in there. Then we have the done bit, and then we have two other bits, the over and the under, the overflow and the underflow. So let's take a look at the count up first and see what it does. The count up enable contains run condition and when the instruction was last executed. Okay, so the count up will, when anything that's in line, let's go back to our program here. So any instruction that is in line with the count up, if all of those instructions are true, in this case we only have one instruction, then the count up bit will set to a 1. Okay, let's go back to the instructions here. The done bit, also a bool. The done bit will set, indicates that the counter operation is complete. So the done bit is going to set when the preset is equal to or greater than the accumulated value. Okay, then we have two other bits, the over and the under. The overflow bit will set, indicates the increment has passed the upper limit of, now I believe on previous versions of Allen Bradley that I've looked at, that upper limit was usually 32,768, I believe, and then the under was negative 32,767. The upper limit is 2 billion 147,483,647. Okay, or a lower underflow limit of minus 2,147,483,648. So there is obviously there may be a time where it may trip that overflow or underflow bit, but that's a disgusting amount of counts before you get there. The difference between the two numbers is just that, remember that 0 is an actual like holding position or bit within the PLC, right? So it goes from 0 to 2,147,483,647, right? And then the negative value, it goes down to negative 2,147,483,648. So the difference between these numbers is just because of the fact that 0 is within there. Okay, preset and accumulated values are double integers. Okay, so but these the over and the under are just going to be bools. Like when they're set, then they'll set as a 0 or a 1 there. Okay, we can see here with the run condition, in that if the logic prior to the counter is true, then it's obviously going to count up, right? So it needs to the instructions that are prior to the counter need to go from a 0 to a 1, right? That way they're going to increment up. Okay, and any other instructions here? Oh, this is cool. It gives you like a flow chart for the count up in the false condition and in the true condition. All kinds of information. And it provides you with an example ladder diagram. So normally we would look at the count up, but we're going to look at both the count up and the count down. Okay, let's take a look at our program now. We're going to add in some additional bits there. So we've got the counter. Let's bring up the counter and let's put it beside, and we'll see all the associated bits. Give me 2 seconds to bring that up. Actually, I should show you how to find that. So let's open up our menu here. And then in order to find the counter and the individual bits for the counter, I was first looking here at controller tags, but if I click on controller tags, the counter is not available there. So next place to look would be here, parameters and local tags. So let's double click on this bad boy. Beautiful. That comes up with our counter. Okay, counter 1 that we created. See this little arrow that's right beside counter 1? Click on it once and it'll bring up all the associated bits that are with there. Beautiful. Okay, then let's get rid of the controller tags because we're not interested in looking at that. And then let's grab this program parameters and local tags and let's separate it from the main program. Beautiful. So now we've got our bits for the counter and we've got our program over here. Okay, let's bring this over to the side and let's try and give me 2 seconds. Let me try and organize this so I've got enough room so we can see the individual bits on the counter, but we can also see our program. Beauty. Okay, so now we've got all of our bits over on the side here that we can keep track of the status of those guys. So let's add in some output, some additional rungs here. So, and we'll do them for each of these bits here. I'm going to start with the done bit because most of the time, like that's going to be the bit that you're going to make use of, right? So let's make use of that by grabbing a bit logic here. Let's grab an examine if closed. Beautiful. And let's grab an output here. Nice. And we're going to associate this one with our counter. So up here, counter number 1, and that's going to be our done bit. Beautiful. That's going to turn on a light. So we're going to go to our outputs now, right? Local 1:0, and that's going to turn on my data. That's going to turn on output 0. Beautiful. I'm going to edit the main operand description, so that's going to be my done bit. Beautiful. Okay, and then I'm just going to add a couple other lines here with all of the other bits. So give me 2 seconds to do that, and then I'll come back to you. Beauty. So now we've got all of our bits for the count up or count down. They're available here, and we'll also see the status over here. Okay, let's download this to our PLC. Excellent. Okay, now I haven't given you like an analogy as to what this up-down counter would be used for. This would be for something like where you have parts coming in, parts coming out, or maybe you have a parking lot or something like that, where you have a number of different spaces. They have photoelectric proximity sensors to see when each space is taken up. And then there's a lot full sign, right? So the done bit would be the lot full sign. And remember that the done bit sets when the preset, and similar to a timer, when the preset and the accumulated value are equal, or you could say it's also going to set or remain set when the accumulated value is greater than the preset value. Okay, so let's do our inputs here. We'll see that input 0 is going to increment the counter up. And every time that this goes true, we should find that the count up goes true as well, right? So let's do that. So input 0 is right here. Let me just click over here. Okay, so input 0 goes true. Excellent. You can see there that the accumulated value has gone up by 1, right? Because I've now gone from a 0 to a 1 state on that input 0, and the count up is also true as well because I'm holding that input in. Once I let go of that input on input 0, then the accumulated value will stay at 1, but the count up will go to a 0. Beautiful. Okay, so obviously we can increment up 2, 3, 4, and then as soon as it goes from a 0 to a 1 state one more time, then the value for the accumulated value will go up to 5. The preset and the accumulated value will be equal. And we will find that the done bit sets. Beautiful. Now the done bit has set. As soon as I let go of that input there, then the preset and the accumulated value are equal to each other. And now the done bit has remained in the on state there. Okay, we can see those values over here as well, right? We can see your accumulated value and the done bit is now true. Excellent. Now I'm going to start to increment this guy right here, my input number 1, and that's going to be my countdown input. And as soon as this goes true, we will find that the countdown goes true. And if that happens, then obviously our accumulated value is going to go down to 4. These guys will no longer be equal, and so the done bit will go to a 0 as well. So let's do that now. Beautiful. So now we now have an accumulated value of 4. We can see there that this is true, so that the countdown is true. So this is true, and that associated light is on as well. Okay, I'll let go of that input, and the accumulated value stays at 4. So the accumulated value will always be a retained value. Okay, let's go down 3, 2, 1, 0. Excellent. So that shows all of our bits there for the count up. Count up is always true whenever the associated bits in front of the CTU are true. The count down is true when any bits that are preceding the CTD are true. And then as soon as the preset and the accumulative value are equal to each other, then the done bit sets. Beautiful. So lots of applications for counters. We'll look at the overflow and the underflow in 2 seconds. The other thing that I wanted to show you was that right now we don't have any other logic in these lines. So let's see what happens if I increment one more time on this count up. Okay, so now the value has gone to 6, and I can just keep going up to any value. So that's an issue because I only want the count up and the count down to go to 5. So we'll do that on the next video. We're going to put in some additional instructions in series with the CTU and the CTD to limit the amount that the accumulated value can go up to. Okay, but yeah, everything's all messed up right now. So now I'm going to reset the counter. Remember that this is going to reset all of counter 1. Both the CTU and the CTD are both addressed as counter 1. So if I press this push button here for my input number 2, it should reset the accumulated value. So we'll do that now. Right on. So you can see that my reset is true. This doesn't light up green, but we can see that it's obviously true because the cumulative value has gone to 0 there. Excellent. Okay, so there are 2 other bits that are associated with this guy, the overflow and the underflow. Not likely that you're going to make use of those bits, but if you are keeping track of like rotation of a motor or something like that, or something where you're getting up into disgusting amounts of counts, then let's see what happens with the values. So let's go back to our browser here and let's look at the 2 values. We're going to try and we'll input these values into our counter, and we'll see what happens to the counter once we get up to that many counts. Okay, so that accumulated value for the count up was 2,147,483,647. Okay, and at that point, my done bit is obviously set because I am much greater than the preset value. Okay, so now we can see that we're at the upper thresholds and the over has not set yet. So let's increment that one more time and let's see whether this overflow sets. Okay, so we'll increment one more time now. Beautiful. And that's cool. Look at that. So as soon as we, can we zoom in here? Let's see. There we go. So as soon as we did that, then all of a sudden it went to a negative value, right? Negative 2,147,000. I'm not going to say the number again, but it went to a negative value. Okay. If we decrement one more time, let's see what happens. And we can see that below that the overflow has now set. Okay. I'm going to keep track of, because that bit is way down here, let's keep track of it here on the right hand side. Okay, so let's decrement that countdown one more time and we'll see whether we go back. Beautiful. Okay, so now we can see that the done bit is still set, but the overflow is no longer set. So if we increase to a disgusting value and go over one more bit, then it rolls over and goes to a negative value there. And let's see if we can get the underflow to happen now. So obviously if we have the value of in a negative value, right, that's our lowest threshold there. So if I count down one more, then we should find that it rolls over and the underflow bit should set now. Okay, so we're taking a look at this guy right here, and I'm going to count down one more time now. Beautiful. Okay, so now we go from a negative value to a positive value. And we can see there that the underflow has now set right here. Cool. So very unlikely that you're going to make use of the overflow or the underflow, but just keep in mind that it does flip the I would say the polarity of that integer there. All right, guys. So hopefully that clears up the counters there, in that we have a count up, we have a count down available. In this case, as long as the preset and the accumulated value are equal, then the done bit will then set. Oh, look at that. Look at that. That's cool. It looks like, see how I've set the preset and the accumulated value the same? Normally the done bit would set, right? I was going to finish off the video and say, all right, the done bit set and we're good to go. That's not happening. So if the overflow or the underflow bit have set, then it looks like there's a nuance there in that the done bit will not be able to set. So let's reset this underflow to 0. And once we do that, can we force that bit? There we go. So if I click here, so I wasn't able, by just simply like typing in the bit, it wasn't taking. So if I right clicked here, go down to toggle bit, that's how I got rid of the underflow there. Beautiful. Now we have the preset and the accumulated value being equal to each other, and the done bit is set. And if we decrement one more time, then they're not equal, and the done bit is now a 0. All right, guys, so we'll stop there. Hopefully everything is clear on the counter. As usual, I've taken way too long to explain this instruction, but hopefully everything's cool for you. Next video, we're going to throw in some additional instructions in line with this input, because we need a way to stop this accumulated value from incrementing above 5 or below 0. So we'll do that on the next video, guys. We'll see you then.